All right, guys, welcome back from spring break. Hopefully you guys had a nice break. So today for your lesson, there's actually two parts to it. One goes with what we did yesterday. And the other thing is kind of the start into this next unit and the main overall idea of what will we be doing in this next unit. So I'm going to start by talking specifically about radical operations. Yesterday, you guys learned about simplifying radicals. And this just kind of talks to you about what you would do with different operations when dealing with square roots or radicals. So for example, you could either be adding or subtracting with radicals. So we'll look at that, and then you'll also see such situations where you have to multiply with radicals. We won't really talk about dividing because it's not quite as important. So we're going to look at these operations here. So for example, when adding radicals, so let's say you have an example that looks like this. 2 square root of 3 plus 4 square root of 3. The key thing to look for when using operations without radicals, especially when you're adding, you want to think of it as like terms. So it's almost like this radical is almost like a variable. If it's the same with both, so see how they both have a square root of 3, that means you can combine them. So this would actually become, you take 2 plus 4, so 2 plus 4, which would give you 6, and then you leave the radical 3. So that would be your answer. So it's just like combining like terms. So for example, if we had a 2x plus a 4x, you would say that's 6x. Well, the only difference is instead of it being an x, it's a square root. You could do that with subtracting as well. So let's say you have something like 10 square root of 2 minus 7 square root of 2. Well, it's the same situation. Since both of these have a square root of 2, you can go ahead and take the 10 minus 7. So your answer would be 3 square root of 2. If they are not the same square root, so if this number under the square root, it's called the radicand. If it is not the same thing, you cannot combine the like terms. So let's say, for example, you have this. You have 4 square root of 5 plus 3 square root of 2. Because this is a square root of 5 and this is a square root of 2, you can't combine them. Okay, so that's important. It's important to know it has to be the same square root. So that's adding and subtracting radicals. Like I said, you can also see situations where you might be multiplying radicals. And this one's pretty straightforward. Let's say you want to multiply 2 square roots. So you've got the square root of 3 times the square root of 5. Here, they don't have to be the same thing under the square root. You can multiply any radical together. What you do is you literally just multiply them. So you take 3 times 5, which is 15, leave it in the square root. You might have a situation where you are multiplying radical by itself. So let's say you're taking the square root of 2 times the square root of 2. Kind of a cool trick with this, if you're multiplying it by itself. Well, if we take 2 times 2, we get 4, right? Square root of 4 is then 2. So if you multiply a square root by itself, so you got square root of 2 times square root of 2, the square roots basically end up canceling. So that's just quick kind of overall review of radical operations. It kind of goes with what we did yesterday, just so you can see it, because you will have to answer a couple questions on this in your Canvas check for today. So this is radical operations. All right, so now for the main part of today. The main part for today is the first type of quadratics that we are going to be solving. So this whole unit is over solving quadratics. And there are multiple ways that you can solve a quadratic. Just kind of refresh ourselves on what it means to be a quadratic is that means it has an exponent of 2. So if you have an exponent of 2, you have a quadratic. So if the biggest exponent is squared, it's a quadratic. Something to remember, I don't know if we ever specifically talked about this. I feel like we did. But whenever you have an exponent of 2, the opposite operation is taking the square root. So if you have x squared, the opposite would be the square root of x. So basically, if you take the square root of x squared, you get x. They cancel each other out. So that's the idea. So we can use this to help us solve for quadratics. Now, when you're solving for quadratics, you're looking for something called a root. And a root is basically what makes your equation 0. So if you have, in this first equation here, if you have an x squared minus 9 equals 0, what we're doing is we're taking this x squared minus 9, and by getting its roots, we're setting it equal to 0. So you're taking your quadratic and you're setting it equal to 0. That's how you get the roots. Okay, so whenever you're solving quadratics, you want it to equal 0. That's the key part here. So from here, you would solve like you would any other equation. So let's say to the side, instead of x squared minus 9 equals 0, what if we just had an x minus 9 equals 0? Well, if I wanted you to solve for x, you guys would all tell me add 9 over, because we're trying to get x alone. So you would add 9 over, and x would be 9. Well, when you have a quadratic, you have to do an extra step. So you add the 9 over like we did over here, right? We did plus 9. And when you add the 9 over, you're left with x squared equals 9. Well, this comes back to what we just said before. If you want to cancel out the squared, you take the square root. So we take the square root of x squared and 9. Here is the very important part, guys. When you take the square root of something, you always take the positive and the negative of that number. The reason why is if we take the square root of 9, the answer is not just 3. Because not only is 3 squared equal to 9, you can also take negative 3 and square it, and it would equal 9. Right? So that's why we would say plus and minus 3. Because again, positive 3 squared equals 9, and a negative 3 squared equals 9. So that's why you take the positive and the negative. Kind of a way to maybe remember this, because it's quadratic, whatever your exponent is, that's how many solutions or roots you should have. So since the exponent is a 2, you should have 2 answers, a positive and a negative 3. So that's what this little plus and minus thing is, guys. So that's really the main idea of what today. And what we call this is we call this solving quadratics using square root. Because basically, you're taking the square root of a number to get your answer. They won't always look like this. They won't always work out like this. This is probably the easier problems of this unit. But the way to think of it is you're just going to solve like you would any other equation. So let's do a few more examples. So if we look at number 1, we have x squared minus 4 equals 0. And we want to solve for x, okay? We're trying to get the roots. So to do that, you would start by adding 4 to both sides. Because when you add 4 here, that cancels. And then you add 4 to the other side as well. So now you have x squared equals 4. Well, from here, to cancel out the x squared, we want to take the square root of both sides. Square root of x squared becomes x. And then the square root of 4 is 2. But remember, you want to take the positive and the negative of 2. So x would be plus and minus 2. Make sense? Okay, let's look at another one. This next one's a little bit more different. So this time we have a 2x squared minus 32 equals 0. It's the same idea. The only difference now is we have a number in front of the x squared. Treat it like you would just if you were solving x. So we still want to start by adding 32 to both sides. So when you do that, you get 2x squared equals 32. Then we need to get rid of this 2 in front of the x squared. Well, to get rid of the 2, you need to divide by 2 because it's being multiplied. So you want to divide both sides by 2. So now you have x squared equals 32 divided by 2, which is 16. So then I'm going to bring it over here. So we've got x squared equals 16. We want to square root both sides because to get rid of the square, we take the square root. And we're left with x equals the square root of 16, which is 4. And again, it's the positive and the negative of 4 because you have 2 answers. Okay. All right, so let's look at number 3 because number 3 is a little bit more different. All right, so we got x squared minus 5 equals 0. So we're going to start with the same process we've been doing. You want to add the 5 over. So we're going to take plus 5, those cancel. So you have x squared equals 5. From here, to get rid of the square, we take the square root of both sides. What's different about this problem, guys, is 5 is not a perfect square. If you go into your calculator and you try to take the square root of 5, you will get a decimal. You cannot give me a decimal answer. No decimals are allowed. You leave it as the square root. So basically your answer would be x equals the positive and the negative square root of 5. And that's how you would leave your answer. Okay? So you want to do anything else, you would just leave it like that. And then the last one we're going to do is 4. I'm going to keep 5 and 6 blank for you to try on your own. This key will be on my Canvas page. It'll be on the list of things for today. So you can use 5 and 6 to check your answers to see if you did it correctly, because I want you to try to see if you can do those ones on your own before going into your homework. Okay, so I'm going to stop at 4, and then you'll be able to do your homework after going through these examples, hopefully. So for number 4, we're taking x squared equals negative 7. So notice this time, the negative 7 is already on the other side. So if we take this x squared equals negative 7 and we square both sides, square root of x squared is x, but we have a problem. See how this is a negative 7? You can never, ever, ever take the square root of a negative number. You'll learn more about negative square roots in Algebra 2, but in Algebra 1, you cannot take the square root of a negative number. If it's negative, then it's not possible. So this actually would be no real solution, because you cannot take the square root of a negative 7. All right, so that's all for today. Make sure you do the Canvas check, because that's how I'm doing attendance for today. And then there's a homework assignment for you to do to have done for Thursday. All right, good to see you guys. Bye.